Okay, so we continue with parallel lines, and parallel lines simply are lines that have the same gradient and they do not meet. So this is a line, this is line 1, line 2, these are parallel lines, and the gradient of M1 will be the same as the gradient of M2. So for parallel lines, the gradient will be the same. Simply, your M1 should be equal to your M2 for parallel lines. Okay, so let's take some example and solve. Find the equation. Find the equation of a line through 1, 3 and parallel to 3y plus 12x plus 1 equal to 0. So in a situation like this, what we need to do is to find the gradient from this equation. So we need to find the gradient from this equation, 3y, so plus 12x plus 1 equal to 0. To find the gradient from this, we need to make y the subject. So this will be equal to negative 12x minus 1. We divide through by 3, and we'll be having y equal to negative 4x minus 1 on 3. So the gradient is the number attached to x, or the coefficient of x, after making y the subject. So the gradient is minus 4. Then we are to find the equation of a line, which is y minus y1 m x minus x1. So the point given is 1, 3. And so we have y minus, your y1 is 3. Your m is the gradient, which is negative 4. Then your x1 is 1. And so we expand. So this will be minus 4x. Negative times negative is positive, so positive 4. So we have minus 4x plus 4. When this one crosses, it turns positive 3. So y therefore will be negative 4x plus 7. And that is the equation of the line. Or we can also leave it in the standard form. So this one comes, it turns positive 4x then plus y minus 7 equal to 0. So this is the equation of the line. This is the equation of the line. Let's take another question. Okay, so we have to find the equation of the line through 3, 2 and parallel to y is equal to 2 on 3x minus 5. So find the equation of a line through 3, 2 and parallel to this. So once again, this is our equation. So the gradient is the number attached to x after making x a subject. So the gradient will be 2 on 3. And the point given is 3, 2. So we quote our equation of a line and we substitute. So we have y minus Your y1 is 2. My m is 2 on 3. X minus my x1 is 3. So we expand. So the 3 will multiply everything. So we have 3 into bracket y minus 2. Go to 2 into bracket x minus 3. So we expand. We have 3y minus 6 equal to 2x minus 6. And so we group light, and so we have minus 6 plus 6, which we all know is 0. And so we can say 2x minus 3y equal to 0 is the equation. Okay, so we now move on to perpendicular line. Having finished parallel lines, so perpendicular lines. So when two lines L1 and L2 with gradient M1 and M2 are perpendicular, then the product of their gradients, take note, is -1. So that is your M1 times your M2 will be equal to -1. That's for perpendicular line. Example. Find the equation of a line which crosses the x-axis at 2 and perpendicular to the line. 2y plus 3x minus 1 equal to 0. We said two lines are parallel when the first gradient and second gradient, when you multiply those two gradients, it should be equal to -1. Then we said they are parallel. So the example says we have to find the equation of a line which crosses the x-axis. And when it crosses the x-axis, it means your y is 0 because at the x-intercept, y is equal to 0. So it means that our point will be 2, 0. 2 for x, then 0 for y. Then the equation we have before us is this. As usual, we need to go and find the first gradient from this and the second gradient from this and use it to find the equation of a line. So we need to make y the subject, and that will be minus 3x plus 1. We divide through by 2. So y therefore will be minus 3 on 2x plus half. So my m1 is -3/2, the coefficient of x. So to find the second gradient, we said that your m1 times your m2 should be equal to -1. So my m1 was minus 3 on 2 times my m2 should be equal to -1. So my m2 then will be -1 over minus 3 over 2. When you solve it well, you're going to get 2 on 3. So now, having gotten this 2 on 3, we can now quote our equation. We are going to now use the m2. Second gradient is what we are going to use. And so the point is 2, 0. So now y is 0, but my m2 is 2 over 3, and my x is 2. So we expand, we're going to have 3y equal to 2x minus 4. And we can group them into standard form. So we're going to have 2x, this one becomes minus 3y minus 4 equal to 0. So this is the equation of the line. Okay, this is perpendicular to the